Hi everyone, it's Daniel from Master in Mathematics, and welcome to this video on the Pythagoras Theorem. Today we're going to be looking at the Pythagoras Theorem once again, but we're looking at how we apply it to find the length of a missing side where it's one of the legs of our right angle triangle. You may notice that it has some bearings references for those of us who are familiar with bearings. However, we're not going to look at the bearings, we're actually looking at the application of the Pythagoras theorem to this particular problem. Our question has given us this diagram, which consists of two right angle triangles, and we will be looking at the triangle EFH simply because the question is asking us to calculate the length of EF by using the Pythagoras theorem. The first thing that we're going to do here is state our Pythagoras theorem. We have the lengths EF, FH, and EH respectively. Now remember, A and B refer to the legs of your right angle triangle, so we are going to replace A and B with EF and FH. Always remember as well, when it comes to the Pythagoras theorem, your hypotenuse is always going to be the subject. So this means we're going to write in EH where we have C. We're going to substitute the values now. EF is still unknown to us, so we leave the notation. We replace FH with 8, and we replace EH with 17. Now we're going to simplify. So let's transpose and make EF the subject, which leaves me with 225. Let's work out EF. When we're solving, it's just to find the square root of 225, which will give us 15. And we'll get the answer for the length of EF. Our units in this particular case was meters, so we also write our answer in meters.